This is a pencast for Atomic Concepts. This is for review number 2, and this is going to cover a lot of things about electrons. So the first thing is that electrons are found in orbitals. These orbitals are areas of high probability. Remember, that's not exactly where the electron is, but it's an area where it most likely will be. When we talk about electron configurations, the ones on the periodic table are what are called ground state electron configurations. That means that these are the configurations for when the electrons are in the lowest possible energy states. If we use sulfur as an example, sulfur's electron configuration is 2, 8, 6, which means that there are 2 electrons in the first shell or principal energy level. That would be the shell closest to the nucleus and with the least amount of energy. There are 8 electrons in the second shell. These electrons have more energy than the first shell, and they are further away from the nucleus. And then in the third shell, or the third principal energy level, there are 6 electrons. Because this is the last shell, for sulfur, the third shell is also called the valence shell. When we talk about the valence shell, we are talking about the outermost shell of electrons. These are also the electrons with the most energy, and they are the electrons that will participate in bonding. When we talk about the ground state, we are talking about the lowest possible state in terms of energy for the electrons. This electron configuration for the ground state is found on the periodic table. When we talk about excited state happens when electrons absorb energy and move to higher energy levels. They can absorb any kind of energy. They can absorb heat, they can absorb light, they can absorb nuclear energy. Any kind of energy that you can think of can cause the electrons to move to the excited state. But the excited state is a temporary state, which means that the electrons eventually move back down to the ground state. When the electrons move back to the ground state, that's when they give off the energy, and they always give it back off in the form of light. It doesn't matter what kind of energy was taken in to move the electrons up, light is always given off when they move back down. Bright line spectrum happens when electrons move from that excited state back down to the ground state, and the energy is released as light. The light, can be separated into colored bands, and the amount of energy, which is what we call the quanta of energy, that was absorbed to move the electrons up to the excited state, is actually the same exact amount of energy that is released as the electrons release light as they move back down. So the same amount of energy to move them up to the excited state is given off as light when they move back down to the ground state, and we call that amount of energy a quanta of energy. It comes from the word quantity. To represent the valence shell, we use Lewis electron dot diagrams, or Lewis structures. These are going to show us the valence electrons only. They become very useful when we talk about bonding, because only the valence electrons are involved in bonding. So we have a short way of showing just the valence electrons by doing this. Our first 2 valence electrons are shown as dots next to each other. Then we spread out the 3rd, the 4th, and the 5th, and then the 6th, the 7th, and the 8th are going to double up the dots on each side to a maximum of 2 on each side. If we want to do an example dot diagram for an atom, for sodium's electron configuration is 281, so sodium gets 1 dot. Calcium's electron configuration is 2, 8, 8, 2. So since calcium has 2 valence electrons, calcium gets 2 dots. Nitrogen has the electron configuration 2, 5. So it has 5 valence electrons, so it gets 5 dots. So now again, remember the first 2 go together, and we spread out 3, 4, and 5. Oxygen has the configuration 2, 6, so it has 6 valence electrons. The first 2 go together, 3, 4, and 5 spread out, and then number 6 doubles up that side. And then fluorine is our last example here, has the electron configuration 2-7, so it has 7 valence electrons. We're going to double up the first 2, spread out 3, 4, and 5, and then double up for 6 and 7.